Hello, everyone. This is Mike Isbitsky, Technical Evangelist with Salt Security, and welcome to another episode of API MythBusters Chalk Talks. Today, we're going to be talking about shift left security. This is really common in the application security space, but also DevSecOps. It's kind of how we scale security program work in industry. Really common these days to kind of see it as an approach. Unfortunately, there's some pitfalls with that, right? And that's kind of the whole theme of this series. Typically, when organizations talk about shift left, they're really thinking we want to shift all of our security testing early into the SDLC. And usually as part of DevOps, you have the concept of CI/CD build pipelines. So we're going to be working from this visual today. Very quickly, I'm going to kind of show the different types of tooling and where they run throughout the lifecycle of code and delivery. And then hopefully quickly kind of describe what some of the pitfalls are here. One thing that's really important to keep in mind is, this is one build pipeline, right? So when you think about multiple technology stacks that an organization might be using, in my experience, that's at least two or more, right? And that's usually if it's a newer company. Companies that have been around for decades that might have some legacy architectures and have been doing development for a while are going to have many, right? You might have 10, 20, 30 different technology stacks and associated build pipelines, right? So that's where some of this complexity comes in. But static application security testing, typically that is done here, right? The source stage. Often as you're creating code within interactive development environments, IDEs, or committing code to version control systems. These days, that's usually a Git-based code repository. The other position within the lifecycle that SAST or static application security testing is usually run is within build stage. And the reason for that is, if you are scanning code snippets, just the piece of code you're working in or just the piece of code you've committed, you're not looking at the fully integrated code base. So you might be missing issues, right? There's typically many libraries and modules you're going to be including into your full code base that becomes part of that running app or API. So you need to be running SAST in multiple stages of code creation and code commit and then code build. So SAST actually gets run in multiple spots. Dynamic application security testing is something that really needs to be run in runtime, right? The app needs to be deployed, right? So it implies that the code is built and running on some infrastructure. Typically, that's a web application server running on some non-production environment, but in some cases, it is actually run in production. It really depends on the organization. So DAST is, really kind of run here. Sometimes it's run here, right? Team test stage. If you think, QA teams might be doing this type of testing, that's not uncommon, right? Because they're doing functionality testing very commonly and maybe doing test automation with something like Selenium or Appium. So it makes sense that they might also run dynamic application security testing tools. They're doing very similar things in how they recreate requests. They're just trying to verify resistance to certain types of security attacks or exploits. It also, DAST is often run here, all right, and it could be run here as well, deployed in production, right? Like I was saying, run continuously against your production deployed applications and APIs. At that point, it starts to look something a little bit more akin to vulnerability assessment or web application scanning, but some organizations do that, all right, and it could really exist there as well. The last piece of this is really software composition analysis, or SCA. These are, very often run at the same time as SAST, right? So as part of code creation and code build, as I source different libraries and open source componentry, I want to make sure I'm not using known vulnerable packages, software packages or container images, because that becomes part of my running code base, right? That fully integrated and deployed code. Very relevant practice, very easy to get that kind of tooling, and it can knock out a lot of low-hanging fruit, so to speak. But that's kind of I'd say the newer world of patching, right? We know this piece of code is going to be vulnerable, so why put that into our running code base? And you really want to catch that pre-deployment, right? So if you found a vulnerable component, you would stall or stop the build, right? And you need to flag on that and kind of fix the library. Hopefully there's an appropriate one that's not known to be vulnerable. But that's actually a problem with SCA, right? You're not in control of that third-party library or open source component. So now you're dependent on maybe an external developer to fix it, or a company that maybe contributes to open source development. So there's kind of latency there. And this actually happens quite frequently as organizations operationalize these technologies. So if you think about these problems, right, I mean, there's a number of places you need to run multiple types of security testing tools. But the biggest problem with all of this testing is that none of these tools can actually detect business logic flaws. They're just not designed for it. Security vendors can't create rules that would accurately be able to analyze your specific business logic and the way you code it, right? There's just no way they could create rules around that. It really requires continuous runtime analysis and behavior anomaly detection, right? And that's kind of where SALT lives here, the API protection platform, but also tries to feed into all of these, right? And that's kind of part of our continuous approach with improving API security posture, right? So as you find things in running code, feed that back to early development stages, make sure things are being fixed in code, maybe on the next release or sprint, you would address that or mitigate in infrastructure such as an API gateway or load balancer, right? And that's the other half of this, is that mitigations for many API security issues don't necessarily occur in code, right? And that's another reason that these testing technologies, a big component of shift left focus, really just are not adequate for API security.